Ya, Assalamualaikum warahmatullahi wabarakatuh and good day to all of you. Okay, now we will continue our next lecture 5 with the topic air compressor. Okay, so the basic idea for compressor is compressor turn gases into power, and there are two main category of air compressor, which is dynamic and positive displacement. Okay, next, this is an introduction of pneumatic system. So pneumatic system uses compressed gas to transmit and control power by using a compressor. And a compressor is a machine that compress gas from a low pressure, usually atmospheric pressure, to a higher desired pressure. Okay, and air preferably used in pneumatic system compared to other gas because of it is safe compared to other gas, and it is readily available in large volume, so you can set whatever volume you want. It is free, so the effect is cheaper cost to develop the system. And this is the diagram for the pneumatic system. Start with air inlet. It will pass through a filter. Okay, and it will go to a compressor, compressed by a motor, and next it will go to a primary air treatment by using a cooler to cool down the air temperature, and a separator, and next it will go to a receiver, and the system will check, and the motor will control the compressor. Okay, next the air will go to a secondary air treatment, and lastly we will go to load, okay, such as a cylinder. Okay, this is the advantages and disadvantages of pneumatic system compared to hydraulic system. So the advantages of pneumatic system: first, air possesses lighter weight, so lower inertia, and the advantage in accelerating and decelerating the actuator. And the second is lower viscosity, so the effect is smaller frictional pressure and power losses. And third, the compressed air can be contained in a container. Fourth, the air exhausted directly back into surrounding environment, and the effect is clean byproduct. And the fifth, the air sources is infinitely available, thus less expensive. Yes. And the disadvantages compared to hydraulic system: the installation of pneumatic system are relatively expensive equipment because it requires installation of air producing equipment such as compressor, air filter, loop tube, dryer, regulator, and etc. Okay, and the second disadvantages is easy to leak and condense. Third, difficult to have precise control actuator velocity and positioning. And fourth, pneumatic are confined for low power application because of due to possibility of explosion, and normally the pneumatic system pressure is low, less than 70 bars or 250 psi. Okay, this is the industrial application that use pneumatic system. For example, stamping, drilling, hoisting, punching, clamping, assembling, riveting, material handling, logic control operation, or etc. Okay, next we will learn about basic gas law. There are 4 gas law. First is Boyle's law. So the absolute pressure of a confined gas is inversely proportional to its volume if the temperature kept constant. And this is the formula: V1 over V2 equals to P2 over P1. V is volume and P is pressure. Okay, next is Charles' law. So the volume of a confined gas is proportional to its absolute temperature if the absolute pressure kept constant. So V1 over V2 equals to T1 over T2, and okay, V is volume, T is temperature. And the third is Gay-Lussac law. So the absolute pressure of a confined gas is proportional to its absolute temperature if the volume kept constant. So P1 over P2 equals to T1 over T2. And P is pressure, T is temperature. And the fourth law is equal volume of gases at the same temperature and pressure contain equal number of molecules. Okay, V1 over N1 equal to V2 over N2. V is volume, N is numbers of molecule. Okay, so by combining all laws, then we will get ideal gas law. Okay, so P1 V1 over T1 equals to P2 V2 over T2, and the ideal gas law is PV equals to nRT. Okay, and R is the universal gas constant. Okay, there are two types of compressor, which is positive displacement and non-positive displacement. So positive displacement, it opens up a cavity to draw in fluid, then closing the cavity to expel the fluid. And this is the examples of positive displacement. Okay, piston compressor, diaphragm compressor, vane compressor, and screw compressor. So for non-positive or dynamic, so it introduces velocity on an impeller or propeller to produce kinetic energy and producing large volume of air in a small space. So the example is centrifugal compressor and axial flow compressor.
Is a mechanical device that increases the pressure of a gas or air by reducing its volume. Compressors are similar to pumps. Both increases the pressure of a fluid and both can transport the fluid through a pipe. As air or gases are compressible, the compressor also reduces the volume of an air or gas. In this video, we will see the different types of compressor. There are mainly 5 types of compressor that are normally used in our industry. 1. Reciprocating compressor. 2. Rotary compressor. 3. Scroll compressor. 4. Screw compressor. 5. Centrifugal. Reciprocating compressors use piston driven a crankshaft. They can be either stationary or portable, can be single or multi-stage, and can be driven by electric motors or internal combustion engines. Rotary compressor. These compressors are not of reciprocating nature, therefore does not have any piston and crankshaft. Instead, these compressors have screws, vanes, scrolls, and other devices which rotate and thus compress air or gas. The rotary compressor can be divided into 2 types. One has blades or vanes that rotate with the shaft. The other type has the blades which remains stationary and is part of the compressor housing assembly. Scroll compressor. A scroll compressor has one fixed scroll which remains stationary and another moving or orbiting scroll that rotates through the use of swing link. When this happens, the pockets of air or gas between the 2 scrolls are slowly pushed to the center of the 2 scrolls, causing the reducing of the volume of the air or gas. Screw compressor. The screw compressor uses a pair of helical rotors where it traps and compresses the air or gas as the rotors revolve in the cylinder. The male rotor and the female rotor are built inside the cylinder. Centrifugal compressor. Centrifugal compressor is usually used in large capacity of compression system. In this compressor, the air or gas is moved in the circular motion that known as centrifugal force. An impeller which a disc with radial blades spin rapidly inside this housing, causing the gas.
Okay, next is criteria for compressor selection. So the first criteria is the maximum, minimum, and mean demand. Either we need to consider the capacity of supply air and other economic factors such as the receiver, the power consumption, and the control system. Okay, the second is ambient condition such as temperature, altitude, and humidity. Okay, the third criteria is method of cooling available. Okay, and the fourth criteria is environmental factors such as noise and vibration. So, for example, special foundation may be required, particularly with reciprocating compressor. And the last is requirement for skilled maintenance personnel. Okay, next slide showing the how to calculate the airflow capacity. So this is the formula to calculate the flow capacity. One is the flow rate of the inlet, okay, normally receiver, and Q2 is the outlet flow rate. P is absolute pressure. T is temperature. Okay. So next is, this is the formula how to calculate the compressor driver power. Okay, and this is the formula. Okay, and to calculate the overall efficiency of compressor, we can use this formula PT, okay, power, theoretical power divided by actual power. Okay, and next is this is the formula to calculate air pressure loss in pipelines. Okay, and next is pneumatic system. So important consideration must be taken in designing and analyzing a pneumatic circuit. So this is the criteria. Okay, safety of operation. So operator must be protected by emergency stop features as well as safety interlock facility that prevent unsafe and improper operation. And the second is performance of desired function. So the system must be relatively insensitive to adverse conditions such as high ambient temperature, humidity, and dust, so system failure can be prevented. And the third is efficiency of operation. So a low efficiency compressor need more electrical power to operate, which increase cost. And the fourth is cost. Cost is the most important aspect in industry. Although air is free, but the compressed air is not, especially if the system is leaked. Okay, that's all a lecture for air compressor. Thank you.